We are just waiting 3 more minutes. Hi, Anselm. Good morning to you.
Indeed. Yes, good morning.
Yeah, so you were
not too bad here. It's
9:45
in the morning, so it's not as bad as 3 o'clock in the morning.
Yeah, it is difficult timing. And I think we really have had a long day. It was very full, not so many breaks, but a lot of interesting materials, and everything has been recorded. So people that could not attend because of impossible time differences can watch back recordings. Maybe you could try to share screen. I know it works, but if you want.
Yep.
Yeah, looks good. Looks very good. Yeah, all clear.
Good. Success.
Yeah, maybe people tune in at the last moment. It's still 1 moment to go, but I will start by, I'll fill the time. So welcome everybody to the last session of today, the keynote presentation session. My name is Peter van Oosterop, co-chair of the 3D Cadastre workshop. Australia and New Zealand have really a long tradition in 3D Cadastre. In the keynote of the previous workshop, there was a presentation called Looking 30 Years Back and 30 Years Forward from Rod Thompson from Australia with respect to 3D Cadastre. So it's fantastic that, I think now we see the next stage happening in New Zealand and Australia in the development of the 3D Cadastre registration. And it is a great honor and privilege to announce our keynote speaker, Anselm Haanen. He has been Surveyor General at Land Information New Zealand since 2018. And before that, he was the Deputy Surveyor General. He holds a Master of Surveying from the University of Otago and has worked in various technical capacities since joining the department in 1978. He was heavily involved in the development of Land Online, New Zealand's automated survey and title system. He has also helped to develop New Zealand's Cadastre 2034 strategy. And the presentation is about the project where Linz is also the sponsor, and that is the 3D Cadastral Survey Data Model and Exchange Project on behalf of Australia and New Zealand Intergovernmental Committee on Surveying and Mapping. Anselm, the floor is yours. I'll start the timer.
Lovely. Thank you, Peter, and certainly appreciate being given the opportunity to present as a keynote. So thank you very much for the opportunity. We're quite excited about this work, which offers a different approach to building a 3D cadastre, which is very focused on the inputs into the cadastre from cadastral surveyors. And we are hoping that this will lay the foundation for the implementation of 3D cadastres in a standardised way across Australia and New Zealand, and possibly for other countries. You'll hear more about that shortly. And this is based on a vision that in future surveyors won't be lodging traditional plans, in paper format or as an image as they have done in the past, but instead be lodging fully digital data sets And once we receive that information and record it in the cadastre, it opens up a whole range of possibilities for how to manage that information and actually build the cadastre. So I'll be telling you about this project, which we've been running now for about 6 months or so. And I'm going to start by just introducing who we are. So we're the project leads, but we work closely with our Australian colleagues. So this is really like the Surveyors General in the other land administration jurisdictions. We sort of use those words, jurisdictional land administration agency. There's 9 of us, so there's New Zealand, and then there's the 8 Australian states and territories. And we're basically in Holland, I know it's the cadastre, and we're similar organisations in each of those areas. And we try and coordinate so that there are standardised ways of working, and in particular in this case, so that you make it easy for the users of the cadastre and surveyors who input information into the cadastre to operate in a similar way no matter where they are. So one of the things about our systems, we all operate the Torrens title system of guaranteed titles. And what that means is that the boundaries normally for most primary rights, freehold rights, are defined by pegs in the ground, monuments, marks, and then the survey information we receive, typically in the form of plans, records those dimensions and those marks and the boundary information, the parcel information in the cadastre. And of course, for 3D rights, it's not quite the same because we don't peg 3D rights. Sometimes they're up in the air or under the ground, and sometimes they're in buildings where the building itself references where the boundaries are. But one of the principles of the systems, they're all different, but their foundations are the same. So we're all looking to modernise our cadastres and embrace digital technology. And the first principle, I guess, is that all the information in the cadastre comes from registered or licensed surveyors. So we don't do surveys ourselves. There are the registered, the competent professionals who put information into the system. And of course, traditionally, they've done that with survey plans, and now we are increasingly receiving digital data in the form of, we use the phrase cadastral survey data set. And what we're aiming for ultimately is for just receiving those data sets, because we know that's where the technology is taking us. And I like to liken it to the banking system. You will remember a long time ago, or hopefully a lot of you can remember, when we had checks and passbooks and so on. And of course, now it's all available on your phone. And we can see that the cadastre is to similarly move to a fully digital basis. So the diagram on the right is sort of trying to provide a generic model where down on the bottom left, the surveyor is going to subdivide the red parcel of land, and they extract the information about those boundaries and parcels from the cadastre. They then go out and do their survey and mark the boundaries or whatever, and ultimately submit that information back into the record, and then the new subdivided parcels appear as indicated on the bottom right. And of course, that's the process we're trying to automate. Just a couple of basics, and I know people talk about 2D and 3D, but from a pure system or regulatory perspective, all property boundaries are actually 3-dimensional. You don't just own what you're standing on, you own the air space above it and the ground below it. And the reason that's important is as new 3D rights are created, it's important that the total volume of space that you own is replaced by new volumes. So if, in the case here, say it was the land above the green space was owned by one person and the land below by a different person, then we can't leave any spaces that are not owned by anybody. And so even though the original right was what we like to call 2D, we have to actually completely replace the 3D space with new 3D spaces, even though, in a 3D sense. So just wanted to make that sort of point. It's really important to the design of the new system and how it tests for new surveys when they come in. Australia and New Zealand already have 3D cadastres. We have had for a long time. That's the legal cadastre, but we have typically recorded that information on paper plans, and we don't really have it coming in a digital format. And we have sort of two types, and I think most of you will be familiar with these. In New Zealand, we call it the unit title. So these are related to buildings, like apartment blocks. The building I'm in is a unit title. So each floor is owned by a different person, and there may be units within it that are owned by different people, as you can see in that diagram. And of course, the other sort is where a right is underneath the ground, like a tunnel, or up in the air, where there may be an easement or covenant protecting some airspace. And obviously, in those cases, they're not always able to be marked. They're not always visible exactly where the boundaries are. And that's where this digital representation can be very helpful. So what we're looking for isn't a 3D cadastre. We're looking for a 3D digital cadastre. And here's a simple example of, it's actually that same survey where we captured the information off that plan just to show how the individual units, and they're shown here in different colours, could be captured in what in this case is a fairly sort of simple model. In this case, we've draped it over the parcel fabric. You can just see those red lines and how some of the buildings actually go below the ground level. So the ground level is a different thing that we obviously need to manage, but it's not necessarily important for the data set itself. And here's a blow up of what one of those plans look like. And I guess this is one of the challenges we face, that somehow that not so much the data that's presented on the plan, but the information that we need to have presented on the plan, how can that be represented in a 3D digital way that still captures all the regulatory requirements? And in particular, as surveyors, we need to know where the boundaries are in relation to the building. So in the top right, you'll see a little panel that describes some of those boundaries. And so, for instance, the top one says the unit boundary is the centre line of the floor slab. And that can be important where there are spaces that may not be in your ownership, they're in common ownership, which makes different people responsible for their maintenance. And there's another example down here. The unit boundary is offset 0.1 metre below the external face of the roof. So it's important somehow to convey that information in a 3D digital data set. We would need to be able to somehow describe that, and that may involve showing the building elements like the floor slab or the walls or the roofs in relation to where the boundaries are. So we separate the boundaries from the building. And that's an important concept I'll touch on again later on. So this project isn't just focused on 3D, it's focused on digital cadastral survey data sets. And we do call it the 3D project, but it also embraces the 2D. And some of the problems that we've experienced in Australia and New Zealand so far are really with 2D, because nobody's doing 3D at the moment. And we have been using Landxml, and we've been reasonably successful in New Zealand. So maybe 90% of the surveys that we receive from surveyors use Landxml. They export it from their survey software, and then they import it into our Land Online system, and then complete the capture and integration inside our system. But many of the Australian jurisdictions haven't had a lot of success with it. Surveyors find it difficult to use. They don't get the support in their software. Each jurisdiction has got their own requirements, and for the survey software suppliers, it makes it difficult for them to implement a solution that will work across all jurisdictions. They really need to develop 9 solutions instead of one that can be customized. And of course, there's no 3D capability really within Landxml that meets the cadastral requirements. So we're trying to work with our colleagues in Australia, say, well, how can we do this better and embrace 3D in the future so that we can actually properly receive digital data sets? So we looked at how best to do this, and this is sort of a broad description of what we were trying to achieve. And I guess the first thing is that we're focused on the 3D cadastral survey data sets and how you exchange it. We're not focused on the 3D cadastre itself, okay? So it's about how we move that information from survey software into the cadastre and out again. That's what we're looking to focus on. We're saying that we think that the technology can already handle 3D data and the likes of ArcGIS and the systems that we're all familiar with. We know the technology can support it within the cadastre. And we also know that the survey software can handle 3D information already. In fact, it's almost our jurisdictions that are to blame for not enabling those two systems to connect with each other in a more efficient way. So we don't think that technology is the stopper here. It's really because those systems are capable of it. It's how we can connect them together. The other thing is that our cadastres are regulated. You know, I regulate the New Zealand system. So the jurisdictions, the land administration agencies can specify the data that surveyors are required to lodge in whatever form, whether it be plans or digital data sets. So we have some control over that system. So just to reinforce that point with the red arrows there, that's the bit that we're focused on, the transfer of the information rather than the 3D cadastre itself. And that's important because that's the way all the data gets into the cadastre. And if we can digitize that process, then the 3D cadastre will come into existence through the fact that we get 3D digital data coming in. And obviously we will need to manage it in the 3D cadastre, but that's a different task. So the approach we're taking then is what we did with Landxml is we developed the Landxml specification to meet our needs. And we said to the survey software suppliers, if you deliver this data in this format, we will be able to consume it. What we're saying now is, no, we're just going to describe the information that we need to have in the data as data, but then we're going to ask them to confirm that they can actually manage that information in their software, in their applications. And particularly, we're going to ask them how best to encode that data and send it to us. So Landxml is both, it's a schema as well as a file transfer. So it's both a model and the encoding. Whereas we're sort of trying to separate those two things so that the model will persist and can be evolved over time. But the encoding may actually change and change quite significantly as technology changes. So we've been using Landxml. People are talking about CityGML and InfraGML and JSON and so on. There will be other formats in future that may enable the computers to talk to each other. And we see that as a IT technical thing. Right? We're really focused on the data itself. And so the idea is that jurisdictions, once the vendors say, yes, we're happy with this model and this encoding methodology, then the jurisdictions, my fellow surveyors general, will then say, yes, we like this framework. We're all going to agree that this is the best way forward. And as we develop our systems, we will look to implement that standard for receiving and delivering digital data. So that's the concept. And so we went out to market and we've contracted to provide these deliverables. So the first one is this harmonized cadastral survey data model, and it's based on the assumption that all our survey systems are very similar. We all have marks, parcels, measurements, observations, datums, projections, and so on. We just do it all a little bit different, and particularly we use different terminology. So the harmonizing is that it covers everything. And of course, that's always a challenge, and we're working with the jurisdictions to make sure that all their needs are met. The second thing is it's going to include both the 2D and the 3D. Now, we've already had experience with the 2D, with Landxml, so in some respects, that's relatively straightforward. But nobody's really doing 3D lodgement yet. And so actually, that's an opportunity for us to put in place a standard, a common way of doing this, that each jurisdiction can implement and avoid some of those problems we experienced with the Landxml and the 2D work, where we had different implementations in each jurisdictions. The other advantage of separating off the model from the encoding is to make it vendor neutral and independent of implementation, which we think is really important, especially over time. And bear in mind that cadastres persist, they will be there forever. And the last element is this jurisdictional mapping. So each jurisdiction wanted to ensure that the new model would meet their requirements. So we've asked the vendor to say, well, go and identify each jurisdiction's requirements and map those against a harmonized model. And that way they'll have confidence that the system will work. We then want the vendor, the contractor, to identify options for encoding and exchanging that. And to be honest, that's turning out to be less of a problem than the modeling. The encoding is, we see as an IT aspect, and how that works, we almost don't care. Whatever works for the vendors of both survey and spatial software and the systems we use for managing the cadastre. So just to emphasize again, the focus is on exchanging the data. It's not on building or designing the 3D cadastre, although that obviously follows on. Once we have all that digital data in digital format, we need to be able to hold that and persist it so that in the future, any surveyor can extract that same information and know that it is exactly the same as it was originally submitted. It excludes design of the database, GIS integration. It doesn't deal with back capture because we've already got a legal record of those rights and interests. And it excludes a direct relationship with BIM. And I'll talk a little bit more about that later on. But that does relate to the relationship of the boundaries to the building and the building elements themselves. So we've contracted the Surround Consortium. They're based in Australia. And some of you may know Rob Atkinson is probably the lead architect for Surround. He's been heavily involved in OGC and ISO standards, which we see as a huge asset to this work. And he's really been developing a methodology for the data modeling. And then the other partners bring different skills, survey skills, project management skills, interoperability, 3D, sort of 4D visualization to the table. So the contractors are doing most of the work for us, obviously, but we're working closely with them in an agile environment. Just to emphasize again that this isn't something that we're doing as a jurisdiction in ourselves. We are working closely and collaborating with the survey software suppliers to ensure that the system works for them, because we see them as key to the success of the solution. To be honest, we're hoping that they can solve this problem for us. If they were to knock on an agency's door and say, we can provide survey software applications that will deliver 3D cadastral survey data set to your jurisdiction, all you need to do is build some way of receiving that. That's the sort of concept that we've got. Of course, it's not quite like that because we're driving this and we're looking to build it in at our end ourselves. But it really is trying to collaborate with the vendors as providing the technical solution. Funnily enough, the people that are missing from there are the surveyors. And of course, they really rely on the survey software suppliers, and that includes spatial software, by the way, to actually provide them with the solutions. So we definitely have surveyors in our mind, and it's not that we're excluding them from the collaboration. It's just we know what we're trying to re-engineer the system here to make sure it works for them. So where have we got to? We're about halfway through the project, a little bit over. And what Surround have done is develop their Ontology Platform, which is really an engine that drives the way the model is built. So what they've done is they've captured all our requirements from each jurisdiction. They're still working through some of the jurisdictions to actually model and capture the actual what's in our regulatory documents and standards and our 3D requirements. And they are like input into this engine. One of the biggest challenges they face, which I'm sure you'll be familiar with, is the common terminology. So they're really mapping all that terminology to common elements. And effectively, they'll provide these inputs into this, I'll call it an engine, and then they'll turn the engine on and the model will pop out the end. And of course, if it's not quite right, they then can tweak the inputs into that engine and it will then update the model. So it'll be quite a maintainable system. It's a very sophisticated platform and system. It includes a multi-level integrated data model. That's the way I describe it. So we asked for a conceptual model and a logical model, but obviously when we start talking about encoding, it needs to be a physical model, whereas really it's more sophisticated than that. It's a fully connected vertical and horizontal model that describes the cadastral data. And of course, the other thing we look for is those jurisdictional inputs to make sure that we call it a mapping in terms of our specification. But the solution to that is to actually develop jurisdictional profiles of the harmonized model. So effectively for the survey software suppliers, they ought to be able to then take that harmonized model and look at the profile to see what needs to be customized and how they build that customization into their applications. This is a diagram that was produced by Surround. I'm not really going to talk to it, other than it is intended to convey the level of sophistication in the system that they've built. Down the left-hand side, you'll see words like modular conceptual model, logical model, implementation profile, context, code lists, transaction models. In the middle, we've got data transfer handling containers, API standards, templates, interoperability, and so on. And then on the right-hand side, we've got the implementation activity where it all actually starts to happen. So we are trying to build a complete system from both a regulatory perspective, a modeling and design perspective, and an implementation perspective. The other thing that Surround have done, being aware of the international endeavours in standardisation and so on, is that they can pretty much produce an OGC type standard out of this system semi-automatically. And initially that would be for Australia and New Zealand because that's the only inputs we've got. But ultimately it's possible that that framework may work internationally. We don't know that for sure. It'll be another year or so before we can see just exactly what that model looks like and how flexible it is to be able to deal with other aspects of cadastral survey data, and particularly 3D data. So just to assure you that their way of looking at things isn't ignorant of what's happening on the international domain, this is another diagram they've produced which sort of shows how their solution and their Ontology platform joins up and ties in to a whole lot of existing standards at multiple levels. So clearly there are a few 3D issues that are going to have to be dealt with as part of this work. We don't quite know the answers to these yet, and I know there's been lots of discussion even here at this workshop on these sorts of topics, but I'll just highlight these points briefly. So the first one is, as I've mentioned a couple of times already, about the extent to which the model includes the building elements. So legally, the boundaries are defined in relation to the building, like it's just, the boundary is on the face of the wall or the center of the wall. Then you could simply record that information against that boundary, or perhaps you could include the wall in the model, and then you could see that it runs down the middle of the wall without having to actually annotate it. So there's a question there. And of course, the way we see it is that all buildings these days are designed with computer models. So surveyors have the option of taking those models, validating them through actual inspection of the building, whatever technology they want to use for scanning them and so on, and then placing the boundaries on that model, which of course is the bit that we're interested in, the boundaries which are related to the building. The second point there is to what extent the model can simply embrace 3D spatial objects is a term that we coined a few years ago. So this is a volume, and perhaps that's the basic unit that we deal with when we're defining 3D rights, as opposed to trying to break that volume down into its constituent elements. And therefore, obviously, the model gets a lot more complicated. And that would be based on the assumption that survey software can produce those volumes, and the tools we use to manage it in the cadastre. I'm just picking out ArcGIS as a way of managing that. So there's a question there. There's another question about managing volumes with unlimited height. That diagram I showed before, clearly there are rights that extend all the way up and down. There needs to be some way of managing that, hopefully within the software. And the other one is the extent to which the model embeds cadastral rules. So we talk a lot about business rules and validation rules and topology rules and so on. But there's a couple of really core ones which are actually fundamental to the way the cadastre works. And just like in a 2D subdivision, you cannot leave a little piece out of your subdivision that's not replaced. You're replacing the original parcel with new parcels, and obviously you can't have overlaps. The same is true for 3D, that if you start with a 2D right that goes all the way up and down, if there's new volumes, even where there is common property, there needs to be a test that the volume is completely replaced with new volumes without any gaps or overlaps. And there are different ways that you can do that. You could build it into the model, which might mean managing the actual faces and edges and common elements, or you could rely on business rules to test that before receiving that information into the cadastre. And the other sorts of rights are, we call them secondary rights, like easements and covenants, which are allowed to overlap each other, but are not allowed to extend beyond the primary rights which they relate to. So these are just a couple of the very core cadastral rules that the system needs to be able to embrace. So where are we at? The project is halfway through, which is why I can't really give you any sort of outputs yet. We're completing the capture of the requirements from all the jurisdictions. We're then going to look to collaborate with the survey software suppliers to confirm the model and look at the encoding options. So bear in mind, for them, it's not just about the data, it's about the tools that they provide to surveyors to create the data. And that's where the value will be driven into their products. The project deliverables are scheduled to be completed by around March next year. We'll then present those back to the ICSM with a recommendation to adopt that as a new framework to proceed the foundation for implementation in individual jurisdictions. And then we'll publish that information as soon as we can. It's not so much that we're trying to keep it secret. The survey software suppliers will know about it, but it does need to go through a sort of a process. We don't want to indicate that it's been adopted until it has been formally adopted by the jurisdictions. We've got a chicken and egg scenario. The survey software providers are telling us that they'll adopt it when all the jurisdictions, the land administration agencies, say that they're going to adopt it. And the jurisdictions don't want to adopt it until the survey software suppliers tell them that they support it. So we're obviously working closer and closer towards that common goal. Implementation, and this is what I think is a good thing about this project, it doesn't actually deal with implementation, because as soon as we get into dealing with 9 different jurisdictions, we've got 9 different implementations. This is through the model and the encoding and just dealing with the transfer. It's providing a mechanism for each jurisdiction to implement independently of the others. So we're quite keen for the market to embrace this, because the vendors, the software suppliers, they are telling us that they want to have a solution that will work across Australia and New Zealand. Some are telling us that they actually want a global solution. Okay, and then they will invest in developing those solutions and competing with each other to provide products for surveyors. And of course, that's a great solution from our perspective. Each jurisdiction then will have to implement it themselves. And obviously that will involve building that capability to hold that information. And each jurisdiction is a different path in its own life cycle, if like. Some are more advanced than others. So it depends where they've got to, what resources they have available financially, staff and so on, how wide they want to go. So maybe that some of them just want to import very simple parcels. Other ones might want to have a fully rich, complete digital data set. But each of those comes with different implications for how well they're managed in the jurisdictions. So our implementation plan in New Zealand, as one of those 9 jurisdictions, is we have our Land Online system, which was built about 20 years ago now. At that time, it was the Automated Survey and Title System. And so we were already receiving 2D digital data sets. And over the next few years, we want to move to surveyors lodging a fully digital cadastral survey data set and not lodging a plan at all. Now that's a major shift for the profession and for our system, because obviously we've had plans for forever. But we obviously still need a plan, a view, and the system will actually generate that from the data set. And we've already developed a prototype that seems to work reasonably well. And the challenge now that we'll be going through is how to then engage with our stakeholders to adopt that new way of looking at these plans. We're going to focus on the 2D initially because we've already got that and we just need to move it to the next level. But in parallel, and we the 3D side of things, because that is the one element where we currently don't have any 3D sense and are still relying on plans. So that's our plan. Some of the Australian states similarly have very ambitious plans. Other ones are sort of running to different schedules. So what we're aiming for is, instead of receiving that plan, we actually receive a digital data set. And bear in mind, this is a sort of a simplified model. The actual 3D model would expect to be significantly more sophisticated than what's indicated in that diagram. But it would be all about loading that information into the cadastre. And as you can see in that view, there's a subtle message there that we've got a single unit showed against all those other property boundaries, which are, of course, 3D boundaries, and they can be extruded up and down to show their relationship to this particular 3D development. But there's none other there at the moment. And of course, once we start receiving these data sets, sure, we might be able to put them in the cadastre, but we will have a backlog of existing rights defined in 3 dimensions that we won't have in the cadastre, and which we may have to back capture and then load into the system. From my perspective, they're not then the legal record of those boundaries, which remains with the plans themselves, but they nevertheless will be a representation that will support a full 3D cadastre where users can visualize the full 3D rights applying to the area. So that's really the end of my presentation. As I've said, we're only halfway through the project, but we are really hopeful that by working closely with the other jurisdictions and with the survey software suppliers, we can come up with a solution for the transfer of that information, which will enable the 3D cadastre to be maintained in an operational way, because that's one of the key lessons we've learned over the years, is to ensure that all new information comes in digital format and that we don't have to convert what's really a paper record into digital format. That's just work for no gain. Once we get that digital information coming in and then look at back capture, we will then be able to start building the 3D cadastre from an operational perspective. And hopefully this time next year, I would be able to give you an update and see exactly what the project has produced and how well our goals have been achieved. So that's the end of my presentation. Back to you, Peter.
Thank you very much, Anselm. Perfectly timed presentation, and already there is an invitation for the next event to show the results of the project. Okay, I will look at the questions from the audience, and remember, you can vote on questions to make them more popular. And I'm now going to the questions that is on the top, and that is there any clue what encoding format will be used after Landxml or Landxml? Could it be Landxml 3D, REF, intra-GML, GeoJSON?
The short answer is no.
No clue.
No, we're leaving that open, and in some respects, we would like to think that there's even multiple ways of doing it. You know, that what we're trying to achieve is simply the transfer of that information from one system to another. The analogy I'll give is we developed this visualization tool that shows what the cadastral survey looks like. And we got a young developer in, and they developed this prototype within about 2 or 3 weeks. And it presented this information, and I said, I wondered, how did the information get out of our database and into the visualization tool? And I don't know. I don't care. The point was some technology made it happen, and it was sorted out at an IT level. And so I'd like to get to that point, whereas I think a lot of the existing examples like Landxml, they are describing the through the scheme and so on in the model itself. So the encoding is might be GeoJSON, it might be some database level thing. Exactly how that works, I don't know. I'd like to think there's possibly multiple solutions. Our requirement would be that no information gets lost in the transfer, obviously, because the integrity of that transfer is crucial.
Yeah, clear, very clear. Then the second question, if 3D parcels are based on references to 3D buildings, what happens to the rights if a building is changed?
Yeah, that's a good question. So we have seen that sometimes where the boundaries are defined in one place, and that's one of the reasons we have requirements in my standards and rules, regulations, that the boundaries have to be defined so that they are capable of being relocated. So if somebody were to change their ownership by physically shifting the walls, and the neighbour says they've shifted the walls and that's illegal, then someone could go back to the plans, or in this case the digital model, and we could say, no, the boundary was defined here and now it's over there, and we need to be able to do that with confidence. So there is a process that you have to go through, obviously, to move the boundaries. Our responsibility is simply to accurately record where they were, and then they can go through a process. If the building's demolished or changed or whatever, then nobody cares because the rights don't exist anymore.
So if we have, say, automated processes to update our buildings, then there should be warnings if there are any rights attached to these changed buildings.
Yeah, it's a good point. What we've sort of have a requirement into our own design of the system that the data set that the surveyor lodges with us has to persist. So in 100 years' time, if another surveyor wanted to find that information, it would be virtually exactly the same as it was submitted at the time. That's the way our legal system works here. That's what's recorded. When the title's issued, the title is issued for how it was defined on that survey. So if there are any changes in the meantime, and we will integrate it into the cadaster, and we may even change the way it looks over time as the coordinates updated and so on, and that you'll get a view of that data that will change, but that's not the actual legal definition of where the boundaries are. So ideally we want both, the original where it was defined and maybe where it is today and how it relates to the current view.
But that means also that you have to have an historic building register, right? Or not? go back
Yeah,
20
figures
years
are,
in time to.
yeah. It comes back again to how we relate the boundaries to the building, and if that's embedded in the data set, so it may not be the complete building, but just the boundaries, because that's all that we're responsible for, then maybe the model and the data set that comes in includes the boundaries and the elements of the buildings that are needed to define the boundaries. Then we persist that and save it for future users.
Okay, thanks. Let's move to the next question. Okay, yeah. If the model works for New Zealand and Australia, is there any reason why it would not work elsewhere?
Yeah, I'm not sure, to be honest. I'm very familiar with the Australia and New Zealand systems, and I'm a little bit hesitant to say it will. I don't want to assume that because all systems are different, and our experience with Landxml in the 2D space was that there were some differences in individual jurisdictions, and that did create some complications. From my perspective, ultimately, it comes down to what the legal system is. So our system in New Zealand is based on certain principles, property ownership, primary rights, freehold rights. We've got a Unit Titles Act that specifies where the boundaries must be located and so on. Other jurisdictions, they may not, I suspect in the Netherlands, but I'm sure in some countries, the buildings, the way the boundaries are described in relation to the buildings may be different. But what we are hoping is that the model is sufficiently flexible that it can say, well, this is how that volume is going to be represented, and whether you record the building and how you record it may be sort of configurable, if you like, profiled within that model. But you certainly can't assume that. And I suppose, to be honest, what we've done is limited this to Australia and New Zealand for purely practical reasons. If we tried to embrace the whole world, we'd probably still be going another 5 years' time. So we've got a specific focus to do it now, but we're not doing it and ignoring what we already know, and this is where Surround are very useful with the work that they're familiar with in the international sphere to try and tie into those international models.
And thank you. And I think that is one of the next questions that is now on top. That is about Standards Australia submitted the new work item proposal for part 1 of LRDM, Land Administration Domain Model, to ISO TC 11. And how does that relate to the New Zealand Australia 3D survey project model?
Yeah. There is a relationship there, and I'm getting out of my depth here now. I'm not an expert in these spaces, but it's probably that the model that we're developing will be very granular, because it will get right down to the, describing exactly what that data that is going to be transferred between surveyors in the cadastre. So bear in mind, this is a model for transferring the data from survey software into jurisdictions, whereas the land administration domain model is a model of the domain for the cadastre. So it's not quite the same thing, but obviously there is a strong relationship there. And then the base elements, obviously parcels and volumes and so on, that are described in the LADM, we would expect to see those in the cadastral survey model. But I think that our model will be much more detailed. It'll have the measurements, the dimensions, the mark descriptions on individual survey marks and reference marks and geodetic control marks and so on embedded within the model.
Yeah, I think you're completely right, that LRDM current version has a very limited survey model. It's really one of the, not so well-defined points. I agree with you there, fully.
Yeah, and that's quite good. It's quite good to have them separate too. I think if we had one giant model to rule them all, it would become unmanageable. Whereas I think having a cadastral survey model focused on the transfer gives us something that's actually manageable.
Yeah, different parts or packages or coherent units of the model. And I think we have time for one last question, but we are a little bit over time, but not so much. How does the project relate to or correspond to Cadastral 2034 strategy?
Yes. So both Australia and New Zealand developed these strategies, and this was really saying, where are we going with our cadastral systems? And in essence, it's recognising that we're going fully digital. And so there's probably two key elements. One is that we're going to embrace the digital technologies. So if we go back 30, 40 years, we used to receive survey plans in hard copy. You know, they were actually foils and plans, and we filed those away and we made photocopies of them for circulation and so on. Whereas we know in the future that this information is coming in digital format. We could just go and file away a digital file, and pull it out and say, here you go. But what we're trying to do is actually integrate that into the cadastre, so have a fully digital integrated cadastre. And one of the things that this has sort of dawned on me more recently, I think in the old days, we had an index map that showed where the parcels were, because it was we called it a record map. It was an index map on paper form that mapped the whole country. But obviously it wasn't survey accurate, and in rural areas it could have been 10, 20, 50 metres out of position. Whereas now with the digital data coming in, tied into the survey control network and the datums, we actually have survey accuracy recorded in the cadastre on our property boundaries. And that means that information can be integrated with any other geospatial information for utilities, for aerial photography, for cityscape models and so on, and it can be put together and joined up, and it will fit because it will be sufficiently accurate. So we've never been able to do that until computers came along and managed this information. So that's really what the Cadastral 2034 strategy was about, was trying to take us into that fully digital space where we had more rights and responsibilities recorded, and that they were able to be joined up with other sorts of information.
So no surprises there.
Yeah.
There is one last question remark added, and I think it was more related to the previous question. The results from your project could be an inspiration or source for the refined survey model in the future, and I think that is a refined survey model in LRDM.
Yes.
Yeah.
It could be.
Could be then also that it's picked up by ISO. Okay, Anselm, I really would like to thank you very much for your presentation and answering these tough questions. I will now give you an applause. You get some present mailed in the near future, I hope. If it not arrives, then something had to go wrong, but really, thanks a lot. It was a great honor to have you here in the workshop at the plenary session. It is really an online event, and also quite exhaustive with the different times. So I really appreciate also the audience for hanging on until the last moment of the first day. The local organizers asked me to say that the floor, which is the other interface of the platform Remo, will stay open until 6 o'clock local time, New York. So that is about one more half hour. And that tomorrow the sessions start at 8:45 local time. So that is 1 quarter later than today, and in the same manner. So track A and track B, and 3D Cadastre will be mainly track B. So I wish everybody a good Tuesday, Monday evening, night, and hope to see you all again tomorrow. And Anselm, thank you very much again for your.
Thank you. It's been a pleasure. Cheers.
Bye-bye.